The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to the webinar. We will start in approximately 3 to 4 minutes from now. We will wait for more people to join in. Thank you very much. Welcome to this webinar, SolidCAM for Milton and Swiss type machines. It's going to be a very interesting session today. This session is going to be conducted by our technical specialist. So I would like to welcome you all to this webinar on programming Milton and Swiss type machines in SolidCAM. In this webinar, we shall show you the ease and power of SolidCAM in programming multi-channel Milton machines and Swiss type automats. This session is going to be conducted by Ms. Marina Vilkina. She's our technical specialist at SolidCAM Limited. Marina is a subject matter expert on Milton and Swiss type programming in SolidCAM. She has been involved with CAM programming for the last 14 years, and out of those 14 years, the last 7 years, she has been involved in the programming various Swiss type machines like Vivia, QuickTech, Jifong, Jinfa, Nomura, Tornos, Sugami, Citizen, and Star. So she has vast experience with different Swiss type automats. She has not only programmed these machines, but has also successfully provided CAM programming, cutting, and training support to these machines. Apart from this, she has conducted quite a few courses in CNC machining at one of the reputed technological universities in St. Petersburg in Russia. We hope that this session will be interesting and informative for all of you who are attending the webinar. I will now hand over the session to Marina, and she will be the presenter now. Oh, Marina, over to you. I'm making you the presenter.
Thank you, Amot. I need just are you sure you make me a presenter, because I don't see the message from the system?
Yes, you can, since you're already the presenter, you can.
I have it.
Yeah.
I have it. Thank you. Okay, thank you for this great introduction. Hello and welcome to the webinar. Today we will talk about programming of complex mill-turn and Swiss type machines in SolidCAM software. I will show you special features and entire workflow inside the software. And I will start from a quick review of SolidCAM features for mill-turn programming. So we will start from the presentation. The fundamental idea of the mill-turn machine is to combine as many cutting operations as possible in one machine to increase its productivity. So we have to combine milling operations with drilling and together with turning and parallel machining for the multi-channel machines. And consequently, there are a huge variety of machines, which we can call like common mill-turn machines, complex mill-turn machines, multitasking machines, Swiss type machines, multi-channel machines, and many other variety of machines. Aside from machine architecture, we need confidence to achieve the best results in programming, verification the toolpath, checking collisions, toolpath optimization, quick part running, exploit your machine to capacity, and turnaround time. SolidCAM meets mill-turn demands and gives you the confidence, freedom in the programming, creative technology presents effect to conduct the production process that you need. One of the most advanced SolidCAM techniques is machine preview functionality that I will show today. Machine preview means that the machine can be checked at every stage of program process. It is not a simulation mode. It takes into account all inputting data that you give to the project. Each country, operation, and setup has machine preview window and machine preview functionality, getting a live feedback from machine with this function. Another very interesting feature that we have inside the software is a tool mounting. Tool mounting is a special interface to position tool inside the machine. You can review all tool posts that it has, and you can position your tools exactly as on a real machine. User can get valuable information about safety tool overhang, turret gantry, and any type of tool post loading before the real machine, a real setup. One more feature is MCO. MCO was designed to operate a machine outside of cutting process. It is critical operation for all multi-channel and multitasking machines. There are a lot of steps the user can program with MCO operations. You can change your tools outside of cutting process, move machine parts, transfer stock, clamp and clamp fixtures, program bar feeder, coolant, air, and whatever extra functions that machine has. SolidCAM provides support of special mill-turn conditions, different cutting modes, the mode where you can share the drive unit with the different tool tables, sharing access, and also you can apply access buttons, which we will see today during the Swiss type programming. Of course, also we have a channel synchronization functionality. We call it channel synchronization table. It guides users through operations order, shows clashes, and helps to avoid them. This is our machine for the considering mill-turn features of SolidCAM 4. This slide also shows the capability of machine simulation module that we have inside the software. You can check the final result with SolidCAM machine simulation model, and of course we will see this module today. Okay, this is the last slide of the first part, mill-turn. So summary, SolidCAM has a flexible structure to support any amount of channels, machine functions, and cutting modes. Okay, now I'm ready to start the project creation, and I would like to show you a CAM part creation inside the SolidCAM. I will go to the SolidWorks environment, and I would like to make a quick review of the first part, which we're gonna program today. We will have two of them, one for the mill-turn and one for the Swiss type machine. By the way, we will have 3 machines today. Okay, our part has a 58 millimeters diameter and 70 millimeters long. I will need both channels and main and the back spindle to program it. Also, you can see that this part has both all types of the common mill-turn elements, the axial elements, radial, and even elements that will need the B-axis. By the way, my machine has a B-axis only for the back spindle, so we will leave these elements for the back spindle, and I'm going to start from this side of the part. So this is the common workflow for all SolidCAM projects. We are opening the part inside the SolidWorks environment, and we will go directly to the CAM, which is inside the SolidWorks. I'm just click on a new and choose the type of the project. Today I'm going to use only mill-turn projects. So this is my first step. I should choose the type of the project and where I'm gonna locate it on a PC. And the second preparation step is similar to the steps on a workshop. I should choose the machine. As you can see, today we will use 3 machines. I will start from QuickTech machine. Lately, we will make a quick review of it. So I'll choose it. And then I should choose where my G54 position should be. So the part 0 coordinate. And because of the pre-settings of the project, I have a possibility to make the number of clicks less. And if I will choose the position of the coordinate system for the main spindle, my system, the SolidCAM, will automatically create the coordinate system for the back spindle. I just apply the position of the Mach 1. This is how we call the coordinate system for the main spindle. And the system will automatically create the position for the back spindle. Also, because I have a predefined settings, I will get my stock dimensions. Let me check them. I will leave 0.5 millimeter on the face, 2 millimeters on the back face for the cutoff operation. And also I would like to add half a millimeter on the diameter. So I will have 1 millimeter more on the radius and 2 millimeters on the diameter. And my stock will be 16 millimeters. This is the maximum diameter for this machine, maximum bar diameter. Okay, what else? Today I would like to use iMachining operations for this part, both axial and radial. So I would like to choose my machine from the iMachining database, and also I would like to choose the material for the iMachining calculation. Now I have my project ready. It is saved on the PC, and now I can go further. The next step for me will be the choosing of the G54 position. For this purpose, I have a special setup window. We call it machine setup. And this is the first function that I described during the presentation, and we call it machine preview. So this is the possibility to get information about my machine and the position of the stock inside it. So I would like to input the distance between the stock face and the face of the collet. As the part is 70 millimeters long, and I'm gonna cut it from a bar, and I have elements here. I would like to put it on 78 millimeters out from my collet. I can see this distance using the machine setup window. Also, I would like to add information for the machine right now about the clamping position for the back spindle, because during the cutting of this part, I would like to do the cutoff when it is clamped in both spindles with spindle synchronization function, which is supported for this machine, before parts were transferred for the second channel. We can make a quick review of the machine before I will add information for the back spindle. So this is two-channel machine. It can supply both with Mitsubishi and Fanuc CNC. The current one will be used Mitsubishi. And here I have the turret, which can operate both on the main and on the sub spindle. Also, I have a special tool turret, which is called gantry. Gantry has only one axis. It has one linear axis. It has Y2 axis, so it can move in Y direction. And also it has a B axis, which we'll be using today to cart my inclined elements. My gantry is programmed in the second channel, and it can operate only on the back spindle. This is how a machine is operated. I have several axes here, linear and C axis on both spindles, and 3 rotary axes, C axis and B axis. Okay, I will continue with positioning my stock, because machine should know where is clamping going to be when I will do the cutoff operation. So we'll click on the position of the stock on the back spindle. We'll apply the stock in command, and now I can see my back spindle, and I can arrange the position of the stock inside the back spindle after part will be cut off. This is it. I can change it. I can go back. Even the country is created and all operations were calculated. I can go back and change these figures, and the system will recalculate all the project. I will put my stock back to the main spindle, because I would like to start from the main spindle. I have my bar here and bar feeder, and I will use it for the cycle machining. Okay. I finished with my machine setup. Now machine and project knows where is my G54 position. Automatically, it will be applied G55 position here for the back spindle for the second program. And now I would like to import some tools. I have a list of my tools, and I have an import functionality here. I will use it and describe what tools I'm going to use today. So I will import my tools with number and position to the tool table. Save it. And now we can see the second function, which were presented at the very beginning. We are calling it tool mounting. For such type of machines which has different turrets and tool blocks and a lot of holders which can be used here. By the way, for this turret, it's BMT turret, and we can have a large variety of tool blocks. We can put a block with double tools, for example, with 4 tools, and all these capabilities are supported with SolidCAM. So here I have a list of turrets supported inside this machine. I have my linear turret. It is on a gantry, B-axis turret, and rotary turret. So this machine has only 3 turrets. Lately, today, we will consider a Swiss type machine, which has more turrets. We will start from a little bit easier example. And here I will apply some tools on a turret. I will have, of course, this turret is a turret with driving tools also. I have a list of the tools on a rotary turret, and I will apply several tools on a gantry. I have tools for the turning operations. These blocks are supported only internal turning and drilling operations in a turn mode, and this block can be positioned in B-axis, and it is driving tools, and they will need a driving C-axis and milling mode on a mill turn machine. So here are my tools. I will save this tool table, and now I can start to program. Now I can start to create my operations. Of course, as always, we are starting from the facing operations. I will go to turning operations. I will name my operation as a face on a main spindle, and I can create, I need chains. I need to input information to the project about what chains I'm gonna cut. I have 2 types of geometry here. It's wireframe geometry. As you can see, SolidCAM automatically created a wireframe sketch based on revolution faces of the part. And also I can use a solid method, which I'm going to show you today. With both this method, I will have the complete synchronization with the part. If I will change my part, I will go back to SolidWorks part. I will change it and synchronize my project. The operations will be rebuilt. So this is what this types of the geometry means. So I will choose my face, and I should check the direction of the chain, which was automatically created, and also I will need to make it longer to start from the stock. This is my chain. I will apply that, and I will apply modifying geometry. With modifying geometry, I can change the initial chain. I can move it in Z and X direction. I can make some extension or trimming, and Also, I have a functions to, after extending, I will apply it to the start of the chain, and also I'm going to apply it to the end of the chain. And now I have the chain for the facing operation. Now I will apply my tool. It will be a tool for the OD turning. I will choose this one. Let me show you. So this is my 55 degrees insert common turning tool. I will choose and apply it. I can change and apply different types of safety levels. You can play with these figures during the part creation. And that's all I need for the first facing operation. Next operation will be OD turning operation. I will turn this part, prepare it for the milling operations. And for this, I'm just make a copy of the current operation, because I will use the same tool, but I will just change the geometry. So I'm going back to my geometry. I have the second operation inside my country, and I will use. I will just show you the wireframe method. So to be clear in this area, so I will choose what I'm gonna cut, all steps and all chains. So this is confusing moment, but don't worry, we have a possibility to skip this undercut, and I can choose it freely. That's what I need. This is my chain. I will apply it. The tool is saved from the previous operation. It is steel tool number 5. And here I would like to apply a roughing type of strategy. I will apply a 1/2 millimeter and a half step, and I will leave some allowance on the surfaces for the finishing operation. I will also apply finish operations, and I would like to extend my chain a little bit further to make the cutting easier for the rest operations, which I will create lately. I would like to extend a little bit my chain about, for example, to 2 millimeters. I will have this extension here. Okay, now I need to check the strategy type. I would like to not perform descent motions, because I'm gonna cut this groove separately with a separate type of tool with a grooving tool. So now I can perform a calculation. And this is my standard turning. Very nice. What else I can do? I can perform some types of links. For example, I can put the optimal from previous or whatever you like. So because these two operations are performed with one tool, they are cut with one tool. This is why we can play with links a little bit more to achieve more optimization of the toolpaths. The next step is the grooving operation. I would like to prepare my part before I will start the milling operations, and I will apply some grooving. So I'm going back to turning operations and choose grooving type, grooving strategy type. Let me name this operation as grooving on outer diameter, and now I will choose my geometry. By the way, we have a special turning view to make it easier to choose the geometry. So this is the geometry for the grooving operation. And now I will apply my grooving tool here. I will choose it from the list. And now I need to apply some type of strategy here. We have a different type of the strategies. It is automatically using the external grooving type. Here I can put information about the steps which I'm gonna use and the step over. So it's a distance in the direction. Also, if I would like to leave some extra material after the rough operation for the finish operation, if my insert can perform the turning type of movement, or I should divide my groove onto stage, first just roughing and then finishing, or whatever you prefer. You can have all these type of strategies inside the SolidCAM software. Especially, I would like to pay your attention on the types of the strategies for finishing. We have different methods. You can apply different types of method according the functions of your insert. So I will use down only type of strategy and also I should think about my approach point and retracting type. I would like to use only X direction because I like that the tool can lead in from right from the top. I don't want it goes through the cut it through the finished diameter, for example. I will put it as a 70. I will remind you that the bar diameter is 60, so I will have 5 millimeters before it will be turned on like Q1 movement. And I will calculate my operation. This is it. Very good. The next operation will be milling operation. I will start from the milling facing elements first, and then I will go to the radial elements. And here, for this deep pocket, I would like to use iMachining operation, but it will be easier for the machine and for the tool, and I will save time of cutting if first I will perform a drilling operation, and then I will use my hole to lead in to lead in my mill before during the iMachining operation. So I will add a drilling operation. I will call it like face drill. And now I will choose the geometry. I will choose the 0, 0 position here. And now I can choose my tool. It will be a 10 millimeter drill. I have it here, 10 millimeter drill. And now I should tell system about the depths of drilling. I will start from 0 level, and I will go till this bottom, and maybe a little bit further because I have a conical tip, and it will be easier for the machine to have it. Type of drill cycle, you can choose whatever your machine has. Some mill turn machines doesn't has a G81 cycle, and you can use G83 with one step, which will be equal to the finish the position, or you can uncheck use cycle, and in this case you will get the code without cycles at all, just G0 and G1 movements code. So this is it. I will apply a one-step cycle here. Okay, now I'm gonna apply my first iMachining operation. I will use iMachining 2D. We have two modules. I will call it iMachining face roughing operation, and I will apply it like iRough operation. I don't want to apply a multi-tool. One tool will be enough for this part. I will apply a chain type, and I will need to choose my chain. We have a smart face option here, so I just click on a face, and I can see the chain. It is automatically created with the system. Now I will choose my tool. Of course, it's a special tool for the iMachining. It has more, it has a special geometry. So I will choose it. It is 8mm diameter. It has 4 fluids, and there is a special tab which is called iData. And I'm going to apply it on this machine. Okay, here is my levels. They looks okay because this is the depth of the pocket. Inside the technology wizard, put the level of cutting to 2 because it is not the milling machine. We have our driving unit on a turret, and it is weaker than the drive unit on a milling machine, but it can have a deal with the mills with small diameters, for example 5, 8, 10, 11, 12. It's okay for the machine, but if you will try to apply more diameter tool, you may have problems because machine can be overloaded in this case. So I will apply the second level for this part, for this geometry, and also I would like to apply some offset. I will leave some material, and I will cut it after the roughing operation. I forgot to name my operation as iMachining roughing face. Okay, and now I will go to links, and here I have a tab which is pre-drill, and my operation knows about the drilling which I performed previously, and I can use this drilling operation, this space, to lead in the cutting tool for the iMachining. A very nice feature. So what else I can do here? I can apply a motion control tab. If I will leave 4-axis unused, I will get the toolpath with X, Y coordinates without involved CA coordinate. It may lead to some limitations on the machine. For example, Y-axis on such types of machine with turret has a limitation. It is not too much space for the turret to move. And because of this, I can apply, for example, Cartesian type of the coordinates. That means that machine will not use y coordinate, and my part will rotate in z-axis to perform the y coordinate, and I will have the output with x and z coordinate. I will calculate that. Okay. Some problems with my tool data. I will just change some range of the speeds and feeds, because maybe this material and I need to check my drive unit on the machine, what I can have inside the post processor. So here we can see that on the rotary turret, I have a drive unit which is limited. On a real machine, it has the higher speed. Now I will try to recalculate it. Okay. Let me check my lead-in. Okay. Nice. Now my machine, my operation will use the pre-drill point, and you can see, because I had a tool with a conical part, and to not damage the mill, iMachining will make some helical movements at the bottom, and only after that I will have my iMachining toolpath here. Very good. Now I will make a copy of this operation, because I would like to perform iMachining face finish operation. This is why I'm going to use the same geometry. I would like just put it like I finish operation. And here I'm gonna use the same geometry, same tool, same levels. What I'm gonna do, because I have just not too much material on the walls, I will increase my machining level. And also I would like to get rid of the offsets. I will not tip them, so I will get the true results without any extra material here. And what else I can do? I can see the previous operation, which will be taken into account during the iMachining finish operation. So this is the operation which I had previously. Very good. For this particular part, for this particular operation, I can still use the face drilling and to lead in my cutter right on this point, or I can untip this, because I have an empty space here, and system will has more facilities for the calculation. And still, I would like to use my Cartesian coordinates during the face. Okay, I will make it lower. No, I'm sorry for that. Okay. Okay, this is my finishing operation. Finish operation. Okay. Now we can perform a drilling on a face. I will choose the milling block again, but I will apply the drilling type. Let me check the diameter of the holes. It's 3.4. I need to check if I have the tool for this. To choose these holes, all I need is just click on a face, and I will have the list of the holes here. I will apply that. We'll see what will happen. Here I will choose my drill, if I have it. Yes, I have it. Let me check if it is mounted on the face. No, it's mounted on as a radial, and this one is mounted as a face. Okay, I will apply it, and here I should choose the levels. Okay, just clicking on a model and get the result. Also, I can apply some step here. This is for G83 cycle, 2 or 3 maybe, I don't know. It depends on the tool. I will have 2 steps. And I can also apply a polar type of the coordinates to rotate the part and to change the Z-axis to not move my turret in Y direction. And here are my drilling operation. And now I would like to mill these faces. I can do this with axial or radial tools. It is matter in terms of tool itself and in terms of the cutting length of the tool. For this particular project, I would like to make it with the axial tool. So I will choose the profile type of strategy. I will go to my milling operations and will choose profile. The Z coordinate of the cutter will be the same as the axis of Mach 1 position, Mach 1 coordinate system. And now I will add several chains. Also, I can create a sketch, for example, and make it with one cut. If I will create a sketch from the hexagon, I will make it in one cut. But I will add several chains just to show that SolidCAM can operate with the several chains inside one project, inside one operation. Okay, my chains are ready. And now I will choose my tool. It will be 8mm tool. Here it is. Okay, let me order it a little bit. Now I should choose my levels. I can apply levels from 0, or I can use, because I had the all these areas are cutted already with turning tools. That is why I can apply some, for example, I would like to apply it like 8mm, and here I will choose the end of the milling operation, the lower level. Now I have to check the position of the cutter. Also, I can do some extension here. This menu is similar to the turning menu. Also, I can apply extensions in the link page. I can also apply some finishing and offsets, whatever needed here. For example, I would like to apply some roughing operation. I will lead an offset, and I'm gonna apply some step here, And on the link page, I will apply a tangential type of the lead in and lead out. So this is my toolpath, and what I can do also, I can leave my tool on the level of the current toolpath to minimize the number of retracts. And also I will give a nice name to this operation. Okay, the next operation will be some radial milling. I would like to cut these areas. I have several here. And on these areas, I will show you the transformation functionality of the system, because you have three elements which are the same, will be used the same tool, the same tool paths, the same feeds and speeds. I will cut one and then make a transformation. It's like a pattern, like copy with the four axes. So for this operation, I will apply a profile type of strategy tool. I will call it radial profile, and I will need to orient to apply some orientation for my cutter, because I would like to apply some radial tools. And for this purpose, I will need some additional coordinate system which will not influence on the output. It doesn't mean that the system will create one more G55, G54 coordinate system. No, this is an additional coordinate system only to position the axis of the tool. So now I will click on the coordinate system button, and I will add one more coordinate system to my main spindle. I will choose a special function here. This function is used to position the coordinate systems. I have no idea about the real angle between the previous position and current position. I just click on a face and I will get the right direction for tool axis. So we do need to align a tool axis properly according the surface of the part. Apply that. And now I can choose the new geometry, new chain. It will be just the geometry of the current profile. Okay, and now I will apply my first radial tool. It will be tool number 10, which is 6 mm diameter and mill. And on the levels page, I will apply the level which is already cutted on the previous operation and the current level of the chain. Also here, I should check the direction, position of the tool according to chain. It is okay now. Looks good. And now I can check what I have here. Also, I would like to apply again. I would like to apply some roughing and finishing here, and I would like also make some extension of my chain with lead in and lead out. And in motion control, I will not change anything because for this operation, I will need my y-axis, and I will apply this, will program this with y-axis. This is what I have here, 2 cuts, rough and finish. The next step is to copy this cut. I have three elements, 120 degrees between them, and I will click on the transformation button. This is my operation name, the operation which I'm gonna copy, and I will use the type of copying the 4-axis. I will include the original operation. The angle will be 120, and I will insert 2 more steps here. And I can see, before I will click apply, I can see my operations, my chains here, just to check if the angle was right, if the angle was okay. I just save that. That's all I need, and no more calculations here. It is calculated automatically with the system, and I have my toolpath. So one more element which I have here is my holes. I will create them with the same manner. I will apply the milling type of operation, will apply drilling. I still have the direction of the tool as Mach 1, 2. This is the right direction which I need. I will check my surface to find the position of the hole center. Just click on the surface, and system will calculate the hole center, will find the coordinates. This is 3.4 millimeter drill will needed for this operation. Let me check again the position of my tool here. I will use tool mounting window to check. Yes, this is what I need, because I have 2 drills with the same diameter here, and I don't remember the exact numbers, exact position in the turret. And the tool mounting window really helps me with this. So I know that this tool has a radial direction. Nice. Now I will apply my levels here. For example, I will apply a little bit further, like 2 millimeters. And what I need also to define the drilling cycle. That's all for the first drill. I will call it radial drill. Now I have it here. I can see it. And now I would like to make a transformation again for this operation. Include the original, type an angle, add the number of steps. And now I can see their positions, these pink dots here. So that's all I need for the drilling operation. What else I can do here? I can machine these surfaces. For these surfaces, I can apply the radial eye machining operation again. So I will create, let me calculate it again. I will create, go to the milling operation, to the milling eye machining operation. I will name this operation as eye machining radial. And I will choose the IRAF strategy. We'll choose my chain. Chain. I will choose the chain like a smart face. Yes. I will need to change my coordinate system first, because this surface is inclined not like this surface. So I will add one Mach 1 3 position. I will click again on my surface to find out the tool position. And now I can create my chain. Again, I will just click on a face. I can see my chain, but I know that I can cross these edges with a mill. So I would like to mark open edges here. These edges will be marked as open. Good. And we'll just trying to calculate this with the 6mm diameter tool. It's tool number 10. I will check it. Yes, it's a radial milling tool. I can use it. Also, I need to care about my levels. Here I have the first level will be already cutted turning level and the level of the chain. Now I will try again to calculate it with the second level and what I can have with my tool technology. I think I will try to calculate it. Okay, my clearance level is not okay. To change this, I will go to geometry. I will go to I just save it. No, we'll go to coordinate system and we'll check the safety levels for the new created coordinate system. I will input the level as 28. This level will be, for example, 32. This will be 35. And this one will be like 40, for example. And let's check if it will works. Each coordinate system has its own set of the levels allowed, the level of the target, safety level, clearance level, and so on. Okay, problems with spin again. Nice. This is my iMachining operation. But I don't like it goes further. I need to check my chain here. Let me check it again, and I will mark my open edges. Okay. Okay. Just leave it like this. Okay. Now I would like to make a transformation here. Again, I have the 3 edges, and I will include original one and make 2 more steps. Apply that. Okay. So now it is time to perform some part transfer and preparation for the part transfer. For such type of machines, let me open my machine. This is my machine. And what I have here. First of all, I need to put my cutting tool, the previous cutting tool, which were milling tool, out from the stock and put the turret to its safety position. Then I will move the back spindle to the main spindle with speed synchronization to have a possibility to clamp the part during the rotation. After that, I will take my turret, will call the tool for the cutoff, tool number 1, I think. Then I will perform the cutoff, and back spindle should go to its home position by Z direction, and then it should go to my gantry to perform the operations on the back spindle. I would like to mention that all these operations should be divided on different channels, because I can operate with turret only in the first channel, and I can operate with the back spindle only in the second channel. This is why I will need several additional machine control operations. So this will be a best example of why we need MCO operations and how we can have a deal with them. So let me show you first the interface of the machine control operations. I have, after milling and turning operations, here I have machine control operation. And with this interface, I can choose any device of the machine. For example, I can choose a rotary turret. And I can see all commands which is available for the rotary turret. Also, it is recommended, strongly recommended, to use machine preview during all these operations. So I can see my turret, and this is position of my turret after it was retracted after the last operation. And here, for example, I can perform some movement. I would like my turret to go, let me do it bigger. So I would like my turret to go to X, for example, home position. So this is home position. Next step, I would like it to go to its Z home position. Next step, for example, I would like to have a tool change. I will take a turning tool, and I would like to change my tool on my future cutoff tool. I have my tool. So this is how we are using machine control operations. This is the one side. This is the basic feature, basic tools that we are using to control the machine, control the devices. But if you have a deal with such type of machines, there are a certain rules, a certain routine of, for example, the cutoff and part transfer process. And to not create all this process from the scratch each time you have a new part, we have the function which is called MCO cycles. So we have all these stages, all these motions, issues already added for the certain machine. And today we will see a lot of different types of MCOs, and we creating MCO for the certain post processor. These commands are connected with machine ID file, and if you will transfer the part from one machine to another, you have to care about MCO operations because they will differ as these processes are differ on a different machines. This window was just for demonstration, but I'm gonna use the MCO cycles. So again, I will take machine control operation, but here I have a list of predefined sequence of cycles, and all I need to do is just input the parameters that may be changing during this process. For example, the first MCO operation will be on the first channel. It will be connected with the turret. As I said, it's a common routine for this machine and also for the machine with turrets. Before you're gonna doing the cutoff, you should prepare the cutoff tool and to position cutoff tool to the place which is appropriate for the back spindle to not collision with the turret and with the cutoff tool. So I'm going to use a rotary turret tool change routine, and here you can see the list which you've seen on the previous MCO operation, which I showed as an example, but you have a number of parameters here. And this list of parameters is all you need. This is the function that are changing from project to project, but you don't need to create all the sequence to each project because it is like common. It is always used. It is recommended with machine supplier. So first step is change tool station. So I need to choose my cutoff tool. Again, this is tool number 1. Let's take a look on it again. This is it, my cutoff tool. Quite long because I have 60 millimeters bar. It is normal for this machine. It can use even a special types of cutoff tools. Also, I have a information. I should enter some information and to check where is my turret during this process. Also, as you can see on this machine, if you using it as an operator, and I will click on the front view, you can see that this gantry is completely closed the view on a turret, and you have to move inside the machine to see what's going on there. This is true for this machine. So this is why we are recommended to use the machine simulation and 3D of machine. It's a good example of why we need 3D of machine, because we don't need to go into the machine and put your head to the machine. You can use only the machine preview window for this purpose. So I have the preposition for the tools. I will put my tool to the safety position, or for example, I can put some figures here, and for example, I would like to put my cutoff tool only in X direction. I don't want to move it in Z direction, for example. Here I should decide if I will use spindle synchronization. It is recommended, always recommended for this machine to use it. And this is the direction of rotation during the spindle synchronization. There is a special technique for this machine. On the first step, you apply a lower speed, and during the cutoff, you will apply the cutoff speed. So after the spindle synchronization, you will have the equal spindle speed on both spindles. So when I put 500 here, my back spindle will rotate with the same speed. This is the special function for two-channel machines. So I will leave these figures as they are. I will just calculate it. And now I'm gonna add one more cycle here. It will be the cycle to move my back spindle and to clamp the part. It will be clamped during the rotation. This is normal for this machine and for all machines we are gonna see today. If you never did it, just short information. So I will use the part catch for back spindle. And for this purpose, I have a message from the software because I have to change my submachine. And during the change in submachine, I will go to other channel because I can operate with back spindle only on the second channel. But system doing it automatically. You don't need to choose channel here. You just click on the MCO cycle and apply the message. So what I have here, let's take a look. I will just calculate that. So here I have the information about the submachine, and this is also information about the apply channel. Okay. This. I will preposition my z-axis. So this is like the safety position for the z-axis. Then I will preposition my x-axis. So it should be the default position for the x-axis is the position near country. It should go to the main spindle to make a part transfer. Then I will go and apply a setup location, which I added previously in the setup window. And also I will input the clamping feed. During this process, I'm not going to use millimeter per revolution. I should use millimeter per minute, so G98. We have this information inside the post processor, and you can input the speed of back spindle movement during the synchronization. I will remind that this process is proceeding during the rotation of main and sub spindle. They rotate together with the speed which we added at the previous operation. So I will apply this. And now, after the back spindle was clamped, I can apply a cutoff operation. I will add turning operation, and we have a cutoff operation here. I will name it as a cutoff, and here I can leave some allowance for example, turning operation. I should choose my geometry here. I will choose this one. We'll change the chain direction. And now I will modify my geometry a little bit to have the cutoff operation from the bar diameter until the bar end. Okay. Now I will again choose the cutoff tool. Here, tool number 1. And I will leave my levels, and I should may put some offset here. This is offset for the back spindle facing operation. And here I will need, it is recommended to put only X value. So I will put some safety value, and this will be the same value for retract. So this is my cutoff operation. Now I need to take the stock and to put it with the back spindle to the gantry. So now I should perform the movement of the back spindle, and for this purpose I will go to MCO cycle again, and I will choose a part transfer back spindle operation. I have the message again because my channel will be changed. The back spindle is programmed in the second channel, and I don't need parameters here because it is known that back spindle will go to its Z home position, Z2 home position, and X2 home position. I will just calculate that. And but it is supported with a certain code, and code will be outputted to the program after the end. The next step here is to prepare my turret. For example, I don't want to leave my turret with this tool. I would like to move it somewhere, for example, for safety reasons, I don't know. We have this cycle, can apply it, cannot apply it. It depends on the workflow you prefer on the machine, because all these menus are completely customizable. So I will apply rotary turret tool change end, and I can choose the next tool, for example, which will be used for the first operation on the main spindle again when I will launch the cycle. It may be T5, for example, or I can leave the cutoff tool here. Okay, now I would like to add operations for the back spindle. I'm ready to do this because I have my stock inside the back spindle. So I will go to first, of course, again, facing operation. I will name it as face turning on the back spindle. And here I will apply Mach 2 coordinate system. I will choose the geometry. This coordinate system became active. I can see it here. And I would like to do just first step is just simple turning from upper level to down, modify geometry again, because I have loans here. Extend it. And now I have a possibility to choose my tool. This will be the tool on the gantry. Let me choose it. It will be here. I will show you where it is. So this is gantry, and this is my tool. As you can see, the position of the tool is completely different than in the turret, and we can support this because for this machine, X direction, X1 direction for the first channel is not the same as for the second channel. They are reversed. So X axis is directed as Y axis here, and even this coordinate system for the turret is rotated. This is why we need powerful tools inside the SolidCAM to have a deal with these machines. But we can do this easily because of the features that we have here. It's machine ID, post processor, and machine file, 3D of machine. We can do this, and we do this. So I choose the tool, my tool. I can leave these levels and I will leave this geometry as finish only. And what I can do, I think I should change my approach because now I will use the right side. I used left at the previous. Okay, this is my my facing operation. If I don't like it, for example, I can do it like with D direction only. In some cases, it is better to use just Z direction. No, not good idea. Okay. I should also change the setup settings because I forget to put Mach 2 coordinate system here. Okay. And from the right. Okay. I will delete it and try again. I will choose my face, PS face again. I will choose Mach 2 and I will choose my geometry. And modify again. Nice. Okay, let me check my tool, G32. Good. And my finishing technology. Again, right corner. Okay. The next step is audit toning. I will just copy this operation and we'll add a new audit toning operation. What I need is to change my geometry. I will start from chamfer. This is my chain. And the same tool, same levels, and in the technology page, I would like to apply roughing type. I will apply, because I have the same tool as in the upper turret, I will apply the same settings for this operation. And I will put a rest material here, and I would like to go descent motions, go to my undercuts to cut this groove. Okay, and I will use to right safety corner again. And this is my toolpath, the common turning toolpath. And now it is time to cut inclined elements. I will cut it with the B-axis, and for this purpose, I will need the coordinate to create the coordinate system again. I will, for these surfaces, I will use face type of milling. Name it as a face. And here I would like to check my chain. I need only this area. And I would like to define my faces. I will define this face. And I'll try to create a chain based on it. I forget to add the new coordinate system, I'm sorry. So I will add in the Mach 2 coordinate system, I will add inclined coordinate system according this direction. Again, I will just only click on a surface and I will get a new position for the Z-axis. This is the tool axis for the direction for the B station. I'll check these figures later during the calculation. And now I will go back to my geometry. I will take my face again, define, and I will take it. Nice. This is my geometry. Now I will apply the first tool from the B station. It will be tool with 6 millimeter diameter. Here it is. I'm going to rotate this station to the part. And I will choose my levels. For example, from here to here. We'll check that. And I will use technology with classical spacing, equal step, and I will need to check my extensions, and I will use some angle here. I will try this. And also I would like to use some corner radiuses for this operation. And also I will need to expand my leading here So let's calculate and check what's going on here. It looks good. And now I will just make a transformation again. I have 1, 2, 4 elements, and I will apply 4 z-axis here. Again, include original element. We'll apply the angle of 90 degrees, and we'll add 3 steps. And I can see my positions. I don't need to create more B positions, more coordinate systems here. That's all I need. I can see my toolpath now. Okay, and I think the last operation will be a drilling operation here. I will go again to milling operations, go into drilling. I'm going to use the Mach 2 and second position of the Mach 2 again. I will just click on the surface and system will find the 0 position here. And I will use my tool. It will be tool on a B station. Okay, and I should check my levels here. Nice. And here I have the functions to have a deal with 5-axis machine. To understand if I will need first or second angle pair, I will launch the machine simulation, and then I will be able to answer on this question. Okay, and now I'll do the transformation again. Okay, 90 degrees and 3 steps here. Okay, of course I can add more operations here, but they will have it is the same manner as on a main spindle. I can also add some drilling and milling operations on the face, add the threading operations, but we have one more project today, and I would like to go closer to the multi-channel machines and channel synchronization things. So here I would like the last operation. If you would like to have both channels operating simultaneously, you should add the special MCO operation, which is called ejection. So or part catcher. According to this operation, the spindle with the part moves to the catcher. Let me show where it is on the machine. I'm going to set up again. So this is the catcher. This is the box, and it can also move. I will show you. So we have this movement on the machine. Spindle goes here, catcher is opens, and spindle is unclamping, and there is a pusher inside which pushes the part here, and then it goes back, and conveyor for the parts can on, and then you will get the ready parts out of the machine, and in this time machine is ready to cut a new part. So this is very important thing. So machine should know the moment when it should drop the part. Now let's go to the channel synchronization table. Let's take a look on this functionality. So this is the list of all operations which I added today to this project. And here we have some buttons to manage with these operations, with their position and with the weight marks. These black lines means the weight marks. So according this, it's a special for this machine, it's L command. On the next machine with Fanuc, it will be M command. And this command appears in both channels because this machine needs two programs. So you will have two files loaded for the first channel and to the second channel. And the link between these files is this weight marks. When the weight mark with a special number appears in one channel, it will wait till the same mark will appear in the second channel. And we have some tools to manage with all this stuff. For example, my favorite tool is Synchronize All Operations. And now I have the weight marks that I need. For this operation, for this machine, it's quite enough, to be honest. The second machine we are gonna consider today will need more clicks here, but for this machine it's enough, no special things. And the only weight marks I will have 1, 2, 3, 4, 5, about 5 weight marks, maybe one more here at the very beginning. And with these operations, I can see that channels will work step by step. First, I will have operations on a first channel, and my second channel will not work. It will stay where it is and without movement. And then I will have my part transfer operations, and then I will have the movement on a back spindle. Of course, for such type of machines, it's not productive way to operate on them. But we need to check our machine simulation, and after that, if there will be no editings of the toolpaths, we can synchronize these operations, and I will show how to do this. Let's check machine simulation. I'm not sure about radial eye machining operation, but let's see. I will start from solid verify mode to check some simple collisions. I'll make it faster. This is my eye machining operation. Maybe I will turn off the eye machining operations because it will take time to wait for them, and it will take time on a machine simulation. So here I have my first collision. Oh, this is because of the tool, I think. So let me just get rid of eye machining operations. I just wanted to show that you can do this inside the Milton mode. It is available, and this particular machine was used with eye machining in real life. So I will just press this, and that's all. Let me check my machine simulation. It will take time to load it a little bit because of online translation, but we are trying to make our STL assemblies as less as possible because of the weight of STLs, the speed of machine simulation, it influence on machine simulation. So here I have the list of my operations. I can go to any operation I would like, and I hope the speed is okay now, maybe a little bit faster. So this is my, oh, sorry, what I have here. I will go back to my cutoff operation and will show you what's going on. So this is my first MCO operation. I put my turret to the safety position and change my tool. And now I'm waiting for my back spindle here. And now I can perform the cutoff. I can see now, for example, I would like to put my cutoff tool further to put it to the X position, or maybe safety home position X. And now I can have my turning operation here and other type of operations on the back spindle, make the speed lower. I'll never guess. Okay, this is my first V-axis operation, and angle pair looks okay. This is milling. So this is how movement is performed. We have the Y movement of the gantry, Z and X and C movement on the back spindle. And I had my drop operation here. After the drilling were performed, I put my tool, my part to the part catcher. Okay, it looks not bad. And now I would like to make a synchronization. So both channels will work together. So I'm going back to channel synchronization table, and I should put the command add new workpiece. That means that when I will cut the back face on the back spindle, the new part will comes here and the cycle will start here. So I will add a new workpiece, get rid of this label. I would like to synchronize this, and also I can put the weight marks somewhere. For example, I would like to synchronize milling operations or whatever I like. So for this machine, it will be enough. For Swiss type machine, maybe you will need more clicks. So I will go to simulation again, machine simulation. And waiting for loading again. Okay, waiting for my holders will be loaded. Now I will just start. Now you can see both stocks are in their spindles. And as I program, I have two facing operations here. And they can be, they are not depend on each other. The only thing is should be checked is if this holder can gouge this gantry, but it is easy to check on the machine simulation, during the machine simulation. I will make it faster. Now we have milling operation here and continuous turning and milling here also. They are separately. So the back spindle dropped the part, and now I will have the cutoff operation. That's all. So I have the cycle and ready to launch it. Good. So Now we can go to the next part. It's a part about the Swiss type machines. The same rules and the software features and the same type of the project are used for Swiss type machines. Before I will start a new project for Swiss type machine, I would like to pay attention on the actual difference between Milton and Swiss type machine. So here on the screen, you can see the type of motion that we have on a Milton machine. The bar, our stock, is fixed in a collet, in a chuck and fixture, which we have on a Milton machine. And we can, because of its diameter and length, we have some vibrations and some problems during the cutting of the special types of the parts, especially small parts. But for the Swiss type machine, this is the main difference. We have our stock movement. So tool is always near the fixing zone, near the this device, which is called guide bush, and we have more rigid cutting, less vibrations. But because of this, we have a special set of rules and which we should satisfy if we have a deal with these machines. So this is the construction that we may have, and this is the rigid construction for the cut-off process. So here we can have our back spindle, which is clamped, as you saw, and we are going to use on the next project. We will clamp our part and we will describe this process in the machine setup window. We have our guide bush. It is not moving. It is used only to support the bar, and there is a certain place for the tools. Tools are not moves in the direction. They move only in X and Y direction, and this is the device to clamp and move the bar stock. This is the main spindle, back spindle, and guide bush. This is the construction that we have in Swiss type machines. And the purpose parts, their target parts is long parts with less diameter. So the maximum diameter which is available for the Swiss type machines is 42 millimeters, and common diameter is about 20 millimeters. So we have the database of different Swiss type machines, and here you can see a couple of machines that we have in our database, and the I can show on these examples the difference also. So if in the previous machine, Milton machine, we had maximum 3 turrets, here we can see a lot of tool blocks, and they are sorted on the mills and turns, even with B-axis, index or simultaneous, and also there is a possibility to change the tool blocks attachments. So you can buy a machine with one set of tool blocks and change them to, at the same machine, you can buy one more 2 blocks additional, milling, turning, and attach it to your machine. So it's a nice way to achieve the best results and to increase the capabilities of the machine. The key features in SolidCAM Swiss type model is that this is the software which is integrated to the CAD systems, SolidWorks and Autodesk Inventor, and we supply, you have the power of associativity with the CAD model. It is easy of use, fast program creation, easy G-code generation, machine simulation capabilities, and we support advanced machines with advanced kinematic, with guide bush, without guide bush device. You have the power of machine preview function, which is critical for such type of machines. We support different holder configurations. Channel synchronization capabilities are also available. You can add a new workpiece and make a channel synchronization. We can apply superimposition mode for the Swiss type machines, apply access patterns, and drive an access sharing. And this is the machine which will be used today at the last part. And now I will go back to my project. I'm gonna open the new part here. It will be a part especially for the Swiss type machine. Let me take it. So it will be info part. Okay, so what do we know about this part? It is small. The maximum diameter is 16 millimeters, and the minimum diameter is only 5 millimeters. And it is not really long. It is only 13 millimeters long. And for this part, I'm gonna use the same workflow. I will click on a new mill turn. And I will apply the machine, which is called GINFA. I will show you how this machine works and the devices from which this machine consists. I will choose this is GINFA machine, and then I will convert this project to the citizen machine. The same process as we had during the mill turn. I will choose the coordinate system. I will choose the center of revolution phase. I will choose my phase and will get my coordinate system here. And as in the previous project, the coordinate system for the back spindle will be created automatically based on the machine requirements. Okay. Here I have my stock. I will give just 1 millimeter more for the outer diameter. Here I have a 0.5 millimeter on the main face for the main spindle and 2 millimeters on the back face. And now I will go again to my setup, machine setup window. This setup window will differ from the mill turn machines because I will need more information to machine. I will need to give the numbers for the working lengths. So here I can see my machine, by the way. I have several turrets here. This is the holder for OD turning tools. This is not driving holder for internal turning and drilling, turn drill operation. This is radial milling tools and axial milling tools. Here I have a special tool table, the attachment for the outer diameter tools and the tools which can be used as milling and also as turning, depends on the holder, which will be attached here. And this tool holder can move in Y direction also as the gantry, which we had. So I will show that these tools can move only in X and Y. Z direction is performed with this clamping device and it moves the bar. And of course, I have the X2 and Z2 movement for the back spindle and Z axis on the both spindles. Okay, so the all programming for the Swiss type starts from the 0 point. So this is 0 for the machine, and I need to move this clamping device to let the bar to give the bar some distance. So this device could move towards the guide bush. So here I should enter the number which is called machine length, and this number is consist from the length of the part, the length of the tool holder, of the cut-off tool, thickness of the holder of cut-off tool, if it will be rotated, if it will have the right direction insert. Also, I will add the allowance for the backface separation and some safety distance. So for this machine, I will apply 35 millimeters. This is more than the length of the part, and on this machine simulation, you can see that the part is moved out of the guide bush, but in fact, during this process, it will be unclamped inside the main spindle. And for the back spindle, I will not forget to put the Mark II. And also, I will need to add information for the clamping process. I will put stock to the back spindle and check what the distance will be preferred for this tool. For example, I will apply 4 millimeters. This will be my clamping distance for the part. I will put my stock back to the main spindle, and now I'm ready to add my tools. I will show you how to add tools to the tool tables because I don't have a lot of holders here. So I will start from the cut-off tool. This is a very important tool for the Swiss type machines. All the processes are started and ended on the main spindle with the cut-off tool. Okay, I will click on a tool mounting to understand where is my tool. So here I would like to rotate it, to flip it, and I will do like this. I will flip my tool, and I will put it to the preferred position in X direction, and I would like to change a little bit my shank because this machine supports the small shanks, 16 millimeter thickness, and here I will make my holder a little bit less, for example, like this. Yes, and I need to put my tool where it should be. It should be moved by Y direction and moved a little bit on Z direction. And as you can see, X direction is 0 because there is a preferred distance which is mentioned inside the programming manual for all tools, which is set to the OD turning tool holder. So I will leave it as it is, and this is my gang. Gang, it's all these tools are supported, are attached to the device which is called gang. Gang on the Swiss type machines moves in X and Y direction on the main spindle near on the first channel near the main spindle. So I will leave it like this. And my next tool will be important. To not spend a lot of time, I just showed you the cutoff tool and other tools I would like to import. I will go to my Jinfa machine and just import it. Okay. Good. So this is my tools now. I will have two OD turning tools, the tools for the cutoff, tool for the external turning. I will have two drills. It will be turning drilling operation, and I will have the tool for the radial milling. Also, I have some tools for the back spindle. It will be the drilling tool, some center tool, milling tool, and one more OD turning tool here. Okay. Okay, so let's create. I will try to do this quickly. Let's create again, starting from the face operation with the facing tool. For OD turning, I will use Mark 1 position. I will use my geometry. I will go to modify geometry and apply extension again. It's a common operations which is supported both with all mill turn and turning projects. So here I will choose my tool for OD turning. I have the only one here, easy to find. And I will leave level as 2 millimeters. That means that my stock will go inside the guide bush collet on 2 millimeters. Tool will not move in Z. Only the stock will move in Z on a main spindle. So here I will apply my finish geometry again, and I will leave my links as they are. Now I would like to perform my face drilling operation. This is quite a long drill, goes through, and I have a chamfer here. So I will apply two operations to cut this hole. I will go to turning operation and go to drilling. The hole diameter is 2.5 millimeter, and I will choose a drilling tool. Here it will be tool number 11. Let me show you it. This is it, my drilling tool. And now I would like to leave my level as a 0.5 millimeter. And in the technology, I would like to have my drilling end as a full diameter. And I would like to have it here at the back face. And also I will leave some extra, will put my drill a little bit further. Also, as in the previous project, we have a drilling cycle, and here we have only drilling and tap cycle because this machine doesn't have a G81 cycle, and all drilling is performed with G83, 87, or with just G1, G0 mode. So I will choose my drill cycle, and I will add some information. For example, I will use 2 millimeter step here. Also, I would like to apply some safety movement in Z, just for example, 2 millimeters here. And now I have my drilling operation. I will make a copy of this operation and will program the hole chamfer. I will need the bigger tool. I will use this one. It's the neighbor tool, 6 millimeter center drill. I will leave these levels, but I would like to choose the diameter value parameter. So I will choose the diameter which I would like to achieve during this operation. Yes, and my drill cycle will be without any steps. It will be like 0. And I think that's all. So I have my drilling operations here. The next step is audit turning operation. It will be a rough operation. I will leave some material and I will cut it after the milling operation. So I will take, for example, on solid type of geometry, and I will choose my solid body, and I have a good direction for the chain, and apply that. The only thing I need to add is extension. I would like to cut till this line, so I will modify a little bit my geometry. I will add 3 millimeters more here, and what I can do, I have to add, of course, my tool also for the cutting process, and I will leave these levels. I will apply the roughing type operation, 2 millimeter step, and some allowance for the finish operation. I don't want to apply finish. And what I want to do is I want to apply only X lead in and lead out. I will apply here from safety corner, and here I would like to pull out my part from the guide bush and leave it for the milling operation. So I will put only X movement here, and part will stay where it is in Z direction. And I will apply that. This is what I have for the rough turning operation. What else I can do for such type of machines? If you cut the hard cutted materials, so like stainless steel or something like that, there may be a problem during the part retracting to the collet. And we have a special function here, which is called the break material corner on stock, and there will be added a special movement to break extra material to not damage a collet. We will have it here. Okay, I finished with the turning operation, and now I would like to add the radial milling operations. I will go to milling operations and will apply profile operation. I will name it as radial milling, and I have to add the coordinate system, a new coordinate system here, again to position my tool, to choose the direction of the tool. Here it is. And again, I will just make a transformation with 4-axis to copy this element. Now I'm ready to add my geometry. Okay. I will choose this profile. And I should choose my tool. I have the only one radial tool. It's 10 millimeter diameter. It is located here. As you can see, we applied a special holder for it, which is located in a special tab inside the tool table. And I should choose my levels here. So I will apply my levels. Just calculate and see what will happen. Okay, I need to change the side of cutting. And also I would like to apply some tangential links here. This is the simple cut, and I will just apply the transformation again. I have 4 sides, so it will be 90 degrees transformation with 3 steps. I can see them and I can apply it. Good. I have this operation very quickly and very simple, not a lot to do. And the last step here is the finish operation, and we are ready to perform a part transfer. So I will apply the turning operation again. I will call it OD finishing operation, and I have my contour here. I will just choose it. I will check later if I will need some extension for this contour, but I will apply my tool number 3 for this. And we'll just apply some finishing operations only. That's all I need. Okay. This is my operation. Now I'm ready to perform my transferring operation. As I said, each machine has its own routine for the transfer. This one has some different type of transferring from the previous machine. The first step is we are calling it preparation of Z1. In effect, it's a preparation of the main spindle. What do we have here? Here, first of all, we should choose the cutoff tool. It seems like the same process as for the mill-turn machine, but the cutoff tool for the Swiss type machines is a really critical information which goes together with machine parameters and loaded with the G code. And here I can apply the rotation speed, and I should put my X and Z axis accordingly, what I would like to use for this machine. I would like to apply 10 millimeters for x-axis. This is radial. That means that outputted coordinate will be 20. And for the d-axis, I will apply a peak point function. We have this function here, and I know that it will be somewhere here. This will be my cutoff position, but I know also that I would like to leave 1 millimeter. So I will change it and put it like 13. And here I can see the position of the tool and position of the part on the machine with a machine preview window. It is very easy to perform these operations with machine simulation. So the next step will be for this machine synchronization of the rotation. So I will add one more machine control operation, and I will choose synchronization, spindle synchronization mode. So this is the speed which will be used for the cutoff operation. Next step I'm going to use is the position of the back spindle. This is called BS clamp position. And here I should check the clamping position. I will just choose the setup location, and the system will take information from the setup. I don't need to think about it if I applied it inside the setup. But after the calculation, I would like to check where is this position. I will take the upper view, and here now I can see. So this is like a safety position, 5 millimeters before, and setup location exactly that location that I mentioned in a setup window here. So again, calculate. And now what I'm going to do, I'm going to apply one more command. It's a special command for Swiss type machines, machines which can move the axis inside the spindles. It's a synchronization command. So with this command, I let the axis, the bar, moves together into spindles. So when the main spindle will move, the axis moves the bar, the back spindle will move accordingly and simultaneously with this command. After this, I'm ready to add the cutoff operation. I shouldn't forget about 1 millimeter allowance, which I left on the preposition MCO. So I'm using cutoff. I will name it as a cutoff, and I will choose my geometry here. I will modify it a little bit at the beginning and at the end. I can do more prolongation if I wish. So it's completely depends on your needs, on how you would like to program it and position. Now I'm choosing the cutoff tool, tool number 1, and I will leave these levels. And this is my allowance, 1 millimeter. I like to leave on this face. What else? It is very important to put the x-axis with the same manner as here. So I will put 20, but for the retract point, I should put none, because on a Swiss type machine, the cutoff tool is left after the cutoff on the bar at the low position, like x-2, and it is normal because from this point, the new loading, new part, new cycle will start on the main spindle. So I will just calculate that. And I can see my toolpath here. So then I should turn off the synchronization mode. If also I can have more before cutoff, I can have more operation here. It's a special mode also for the long turning, for example. So I will add MCO and I will add synchronization off mode. And after that, as on the previous machine, I need to take my parts with the back spindle and to put it to the second channel. So I will go to the next MCO operation. It will be operation on the second spindle, and it is back spindle home after transfer operation. It doesn't have any additional parameters, but it will output some code to the program, the G code. And the last one is about the bar feeder. It's end of the first channel. I will change the channel again for this. And that's all I done with the part transfer. Now I will add just a couple operations on the back spindle, and we can go to the channel synchronization. I will go again to my facing operation on the back spindle. Hope I will not forget to change my mark to my coordinate system. It should be the coordinate system for the back spindle. And now I need to check. I would like to wireframe geometry because I have a radius here, and I would like to be sure that I will choose it. This is it. And what I'm gonna do here, first of all, I will apply the OD toning tool, which is located on a station for the back spindle. It is here. I will apply it. And on the levels page, I will leave this. I will again use only finish mode. And let's consider our links, because now we have Z direction. Z movement is again the movement of the stock, but it is clamped on a back spindle, and I have my tools fixed on a Y2 station. I would like to have more safety distance here, so I will use only Z approach, and it will be quite large. It will be on G0 command, so I can do this. The same will be for retract, but I would like to use some leading here to start from this point. So I'm going to use like a tangent, and I will have only just 1 millimeter here and 1 millimeter extension and 45 degrees here. Let's see what will happen. So this is my toolpath for the facing. It looks strange for the mill-turn machine, but for Swiss type machine it will be very good because the part will move safety and it will retract before going to the next tools on a tool table. Okay, what I need only drilling and some milling operation here. That's all I will add. So here I will have 2 milling drills. It's 2.7 diameter drills. I will choose my Mark II coordinate system again, and I will just click here, and I can see a list of my drills. It's okay for me. Now I will choose my tool. It will be a drill in the milling block. So this tool has a special block which can take the use with the drive unit. So now I will put the information about levels like this, and I would like to put it as a full diameter and like 0.2 millimeters lower than the full diameter, and I will leave like this and calculate it. What I want to do here is I would like to apply a polar movement. I don't want to move the tool in y-axis. I would like to move the z-axis. So I will apply it as a polar movement. The next will be these chamfers. So I will just copy this operation, and we'll apply, we'll add a chamfer here. So I will change my tool. I will use a bigger tool here. And also what I need to do, I need to change my levels. I would like to apply it as a full diameter, and I will choose my diameter here. I don't need this. Nice. Have the same technology, the same motion control here. And one more drilling operation with chamfer. I would like to add chamfer here for this hole, and it will need a new geometry, and but I can apply the same tool. So I will go here and just choose my 0 position, apply it, and I will leave this tool. I need to change the diameter value here. It is smaller, and it's okay for me. And the last operation is the milling operation. So I will choose it from the milling operations, and it will be profile operation. I will call it BS profile. For example, BS profile. And here I can use this coordinate system, and I would like to choose my geometry. It has several radiuses. I will choose it like this. Step by step. So I need here I will choose my milling tool on a back spindle. It will be 4mm end mill. And I will go to levels and choose them a little bit more for the tool to be sure that it will cut all the geometry. In the technology page, I would like to check the tool side. I will use right, and let me check what I have with rough and finish, because I would like to add more movements here, and I would like to apply a clear offset function. And I think I will need some tangent movement. Okay, this is what I have for this separation. What else I can do for it? For example, I would like to apply it with the Cartesian coordinates, again, using my z-axis. I'm not gonna use the y-axis for this operation. This was the last operation in the tree, and now I can perform the part ejection process. It is called ejection. I will just apply it, and now I can go to my synchronization table again, and now I will just check my process, and I know that here I will need additional weight mark. It's like requirement of the machine. Let's check the simulation, maybe this here too, and then we can create a cycle process with channel synchronization. I will go to simulation and machine simulation. Should wait a little bit again. Okay, let's check what's going on the main spindle. We have our turning operation, and the movement is performed with the part, with the bar. This is how milling operation is performed. The stock should goes out from the collet, and it goes to the tool. This is my finish cut, and then we can see we will see the cut-off process. So now we have our cut-off process, and tool and the stock goes to the back spindle. That's all, and machine is ready for the next part. And again, to perform synchronization mode, to have the cut in both spindles, I will have to add a new workpiece here, get rid of this weight mark, and also change a little bit. I would like to start this two operations together, but after ejection, I would like to separate it a little bit. I need to add one more weight mark here. It really depends on machine, the number of weight marks and how this process should be organized. And now we can check the machine simulation together with two channels. It took just a few clicks to create the program with synchronized cutting in two channels together. Okay, I will try just run the machine. And now I have all operations together. Of course, operations on the back spindle will be faster, and the back spindle will wait for the weight marks which is on the main spindle to perform the cutoff. This is how it's waiting. Okay, cutoff operation, and that's all. Okay, and the last subject for today is how to convert this process to some other machine. For example, we will review the Citizen machine, quite popular machine, popular model. It's Citizen L32 machine, and you can see now that the number of turrets and the type of turrets a little bit differ from the previous machine. Of course, turrets for the back spindle, you can see them here, are the same. Also, you can see that main spindle of this machine is located on the right side. For the previous machine, we saw it was on the left side, and maybe Z-axis signs will differ, so it will take time to convert this part to some other machine if you're going to do this manually, but I will show you how to do this inside the software quite easy and fast. And also what I want to mention here is we don't have turn drill tools here. We have two turn drilling operations for the GenFA machine, but here we don't have this attachment. We have only OD turning, radial milling, and B-axis milling tools. But we have some tools for the deep drilling on the back spindle, and I'm going to change the type of operation and to put this drilling it will be performed on the tools on the back spindle. So I'll try to do this quickly. So first of all, to do this, I will go to my CAM part. And here I can choose another type of machine. It will be Citizen machine. I will repeat again, the process of the cutoff, some MCO operations, they will differ from GenFA completely. And GenFA machine had a FANUC. Oh, I forget to show you the G code. I'm sorry. I will show you G code first. So this is my G code for this machine. The GenFA machine needs it has a FANUC controller and it has a FANUC type output, but in the very beginning you can see a special codes here. It is for the main spindle movement, for clamping and unclamping, preparing the bar. Then we will have, this is what we called weight marks for this machine. As you can see, we have these weight marks in this is program for the main spindle, program for the back spindle, and with these weight marks, the program will start together into spindles. this is how it gonna happen. So here we have our T3 tool, T11 tool, all these tools, our facing operation, drilling operation, chamfer, then we will have rough turning operation. In the same time, we will have the facing operation on the main spindle. This is code for the C-axis on. So we position C-axis, so whatever it looks like, it is similar to mill-turn machines, but signs may be reversed, and we need to remember about the weight marks. So here we have the operations on the back spindle till the part catcher. This is the ejection cycle, and it will wait for M1002 weight mark on the main spindle while it goes further. So these weight mark will appear during the part transfer process. So here we have all the operations, milling, turning operations, the last turning operation, and this is the preparation for the cutoff. During I have an ejection cycle, machine is calling my cutoff tool, position the stock, position the tool. I have separately my synchronization mode. There is a special M command to synchronize the spindles of this machine, and during this process, it's a more complex process, and it will be not easy to write it manually, because there will be need to perform a nice synchronization. We need to wait. Second spindle is waiting while I will turn on the synchronization on the main spindle. After this command, the back spindle starts to rotating with the same speed of the spindle, and then I will call my back spindle. This is the special code offset on the CNC to position the back spindle, because as you can see, it position it according the part coordinate system. It is not machine coordinates. So it's safety position. This is the clamping position. It is calculated from machine setup. Then I will have the cutoff process with the Z synchronization special commands for this machine. And then I will have some codes to put my back spindle to its home position, and some commands for the bar prepare to the next step. So this is the code for the FANUC for the current project, normal for FANUC type machines, and the difference will be in weight codes and in M codes and in part transfer process. It really depends from machine to machine. Now I would like to put this part to a completely different machine, which will have the completely different process of cutting and different tool posts, but I will do it, I will not need to rebuild all the project. I will choose the Citizen machine here, and I will have the message from the system if I would like to back up this project with the previous machine, or I would like to continue and forget about previous machine. So I can have both projects with different machines. And here, the first message which I have here, it's connotation of submachines, because now it's system analyzing the Citizen machine, and it can see that the tool posts are different. So I will have to put some tools manually, because this machine doesn't have the same tool post as the previous machine, but the capabilities will be the same. It also have it, but in some other place. So I will use the tools from Gang as a OD turning tools. This is tools for the back spindle, and my Citizen machine has also tools for the back spindle, for the milling and for the turning mode. And I will click OK here, and I will apply that. Nice. Now I have some messages also from the system, red dots and so on. But first of all, I would like to to delete all MCO cycles, because this machine will have completely different MCO cycles. I will also suppress the operations on the back spindle, because I can perform them only after the part transfer. So, but I have MCO cycles for this machine also inside my pod, so I will not spend too much time on this process. I will delete it, and also I will delete these operations and part ejection, because this machine will have some other part ejection cycle here. Okay, next step is to put my tools to the new positions if needed, because I have now my, for example, turning tools, drilling tools on the position of the OD turning tools. Of course, I should change it. So I will choose another type of turret. For example, as you can see, this drilling tool, it's a turn drilling tool. I don't have positions in the gun here, but I have a special position for these tools here. And I'm going to perform the turn drill on the main spindle with these tools with back spindle. So I will put these tools as T21, and I will change the number. And also I will change my second turning tool position also to T20, for example, 23 position, or I can leave 22 position. What else I will need to do? I have the milling tool here. I would like to put it here because it will be the same radial tool, the same radial operation, and I will not need to recalculate all this stuff. But I would like to change the holder, because these tools will use other type of the holder, and I will choose the new position for it. It will be position number 8. And I will apply the holder exactly for this machine. You can have the STL database. I will go to my citizen machine and will apply this holder. Also, I need to rotate it a little bit. I will rotate it. And now I will have my holder. Okay, I rename it. And now let's check the back spindle tools. This tool's looking okay, but I will need to rotate the turning tool here. So I will choose it, and I will a little bit rotate it to choose some other direction, flip it around and pull it out. I will need a special holder here. And also what I would like to do, I would like to change a little bit my cutoff tool, because it was used, the previous one, it has 12 millimeter thickness of the holder, but for this machine I need to use the 16, oh, sorry, this is not about insert. It's about the tool holder. So I should change my shank. It will be okay. It will be 16 millimeters, and I should position it accordingly. Okay, and oh, it looks good. 16, and maybe here I would like 16 too. Nice. So this is steel tool number 1, the cutoff tool. What I also can do, for example, I can flip it, choose it like a left or whatever I'm going to use, but I leave it as it is. So I will save my table, and Now I need to check my setup again. I will leave the same setup values for the main, for the back, to climb the part. And here I have a message that tool is not from the submachine turret. That means that for this operation, system uses the OD turning tools. This is the turning tools, but in fact, I will have to move these operations to other submachine. I have a special command here, change submachine, and I will use T2123 submachine for these operations. Also, I will have to move the radial milling operation to submachine T78. And for this particular operations, it will be very interesting because I'm going to cut it with the back spindle tools. And for these tools, I have to add some MCO cycles. So I will again go to, let me go first to the channel synchronization and just get rid of error messages here. Also, I would like to calculate all the separations. Okay, and now I will add some extra MCO cycles here to have a possibility to cut with the drilling tools on the back spindle. I need to position my stock first. I have a special cycle to position the stock. It calls before applying G620 access button. And for this MCO, I will have to decide the position of the stock for the drilling operation. I will have this position here, and I would like to change it and apply it like 20 millimeters. So stock goes out from the guide bush, and then this tools goes to the stock, and stock is not moving, only back spindle with these tools moving to perform this drilling operation. It's a very nice feature, very nice operation. It is used for the deep drilling. And also, sorry, I will need to change to move stock back after this operation, and I will add machine control, one more machine control operation, and I will move my stock back to the collet. Okay, and what else I should do? I should change the retract distance for this tool, because it is not enough. Because this movement is the movement of the back spindle, and it should be saved. This is why I prefer to put it as such a big number. And also, I would like to check the calculation for these operations and check if simulation will be available without any problems. So I will just perform a quick check. So I will have my drilling operation, and what about the second operation? Okay, looks nice. Now I will calculate operations again, and now I would like to add MCO cycles for the part transfer. Part transfer will gonna be performed after they finish turning cut, and here I will use MCO operations again, and I will have my first MCO, which is called Z1 positioning for cutoff, and again here I will need to choose my cutoff tool. It will be tool number 1 again. And again, as on the previous set, I will pick the point of the cutoff position of the tool. and I will add some 1 millimeter here. Okay, now we can check it. So this is my stock, and this is my cutoff tool here. Now I will add a special operation for the movement of back spindle. It's a Z2 positioning for catch, and I have a set application as a default. This is where the part will be clamped. And the next operation will be synchronization of Z-axis. It's a must. Okay. And this is my cutoff operation. And after it, I will add the synchronization of command. And again, some couple of MCO cycles to retract my back spindle, move after cutoff for the back spindle, and programming some for the bar change on the main spindle. This will be the end of the main spindle program. Now I will unsuppress the operations for the back spindle. We'll calculate them. And my last operation, again, will be the ejection. Part eject. Before I will go to simulation, I would like to check my synchronization first. And for this machine, the interesting thing is that it uses what is called axis patterns. It's a special G commands, G600, and for the machine, it means a little bit more than just a simple G code, because using just one of these commands, a machine knows how many axes it can use in this set of operations. And for example, during the part transfer, it knows the zero position for the back spindle and where to even move back spindle after this operation. So it's a special citizen type of programming. And because of this, I have to add more information here. First of all, I would like to create synchronize these operations. I will again add a workpiece to the back spindle, and I will add additional weight mark to separate the setup, the beginning, and the processes which should go together. Then, according to the plan, I have to cut on the back spindle with face operation on the main spindle, and after that I can after part ejection I can apply my drilling operation on the main spindle here. So when this process will end it, machine will be ready to perform a deep drilling operation here. Now, so what tool patterns, access patterns I have here? It's a special commands for this machine, and I will apply the pattern G630 because this pattern enable machine to use all axes on the main and on the sub spindle. But for example, before the part ejection, I would like to add one more weight mark. And I use also G630 again. And for the preparation before the drilling operation, I need to change the axis pattern type. And here I will apply the axis. So I will perform this process with X2 and Z2 axis. It will be the back spindle operation with the tools on the back spindle. Here I will apply again the neutral cycle G600, which allows to work only on just one channel. After that, this is my part transfer. Part transfer is always happening with G650 command axis pattern. I will delete this weight mark, and here I will use the same cycle too, and here I can use just G600 cycle. It's okay for the machine. Okay, and now we will perform the simulation. Together on 2 channels. So I didn't spend a lot of time on converting. I didn't create more operations, didn't choose geometry again, recalculated, for example, axis directions. I don't think about axis signs because they will be calculated automatically from the post processor. All I need to remember is the special features of the machine, because these machines are completely different, and there are different rules for this machine to operate. All I need to know is the specific of the machine. So now I have 2 parts. I can see my part on the back spindle, and I can start the process. So I have both operations here, and my main spindle is waiting. Let me show you this process again. Okay. I would like to see it again. So this is what is happening. Let me show you again what I have here. So my part is positioned out from the collet, and with G620 axis pattern, my back spindle goes to the part, and it knows that I'm going to use these tools. It's a special axis pattern for these tools on the back spindle. And here I can see the process. I perform drilling and chamfering. That's what's going on the machine. Then I lead out the tools, because I know that I will need my back spindle during the part transfer, and I retracted it with the retracting distance. I can make it further. For example, I made 100 millimeters. So let me continue with this. It's turning operation, and then we will have milling operation. This is our milling operation, no changes, and this is the finish operation. I will take a break here, and I would like to see my cutoff operation. So this is what is happening. I called the cutoff tool. I position my spindle. This is the safety position, and this is position of the clamp. And I can do my cutoff here. That's all. I can also show separately what's going on the back spindle. For example, it is nice to check my polar movement. for the back spindle here. What I have here. Yes, my part rotated with Z-axis, and the tool holder didn't move in Y-axis. And for example, the profile. Also, I have a possibility to choose the side of the cut. For example, from X plus or X minus. Also, we have this possibility. For this purpose, all you need to do is just change the submachine on the tree. You don't need to recalculate the project. Okay, now I would like to check my code. I just want to show you that it will differ from the FANUC. And I'm going to set up, and I will choose G-code generation. And I don't know, for example, like this. Okay, this is my program. First of all, I have only one program for 2 channels, only one file. Inside this file, the separation is performed with these signs. It's a special sign for Mitsubishi CNC. And at the very end, I have one more block. It's a list of the parameters for the machine, which is loaded on machine, and machine knows about these parameters before it will start to operate. To show you this this program to more convenient way, I would say, I will save it here. And I will try to open it in some other software. So here I have a special software to check the citizen programs. So this is what is called access patterns, and this is how it's like additional weight marks for this type of program. Citizen has 2 types of weight marks. First is access pattern. And the second is a normal Mitsubishi weight marks like this one. So this is the beginning of the program. This is our face operation, and then I have my back spindle operations, everything I would like to get on the back spindle, and after that I will have my drilling operation. I prepare my stock for the movement, and then I have the drilling operations here. It's a drilling with the back spindle, a special access pattern, and then I continue with operations on the main spindle, and then I call the tool for the cutoff again, synchronize. You can see that code is completely different from FANUC. Machine is different, code is different, the sequence is similar but different, and it didn't took too much time to put the parts from one machine to another. This is some code for the back spindle to clamp the part. This is the code for the cutoff itself, and this is the end of the program and a special set of the parameters. Okay, I think that's all for today. It was too long, I know, but I covered both milling and toning, and I showed all essential things about the software and about the features that we have. We have a lot, and all these features will help you to easy and fast program any type of mill-tone and Swiss type machine. We have a very flexible tools for this, and I demonstrated them today. So thank you for your attention.
Thank you, Marina. Thank you very much for your nice and in-depth presentation. It was very nice. There were several questions during the webinar, and I kept on answering all of them. There is also some questions coming up, whether we can give them for the training parts and machine files. Yes, towards the end of the webinar, we will collate everything and we'll let you know when this can be supplied to you. Stellion, we can do that. Most of the questions were related to the product and other things, and I kept on answering. I think I must have answered about 40, 50 questions till now in the webinar when it was happening. I thank you very much. I know it was a pretty lengthy webinar. 3 hours, 20 minutes is a pretty long one. I think we went completely in depth with the product, and I hope it was worth your time spending on this in this session. Thank you very much, and we hope to see you some other day with some other topic that we will show in SolidCAM. Thank you. Take care. Bye-bye.